In this video, we're going to talk about something called end behavior. That's end behavior on the left side and end behavior on the right side. And those are two different things. So we're going to talk about that and what that means. But first, I'm going to talk about a line. This is with a positive slope and a negative slope. And then parabolas with a positive coefficient and a negative coefficient. We're going to see. So if we have a line and this is positive, the slope is positive, then we have something that looks like this. Simple, very simple. Very, very simple. And if we have a negative slope, so if we had y equals negative something, x plus b, then that would be a negative slope. That would be something like that. Okay, this is pretty good. And then let's look at parabolas. Recall, if you have a parabola with a positive leading coefficient, then it opens up. And if you have a parabola with a negative leading coefficient, it opens down. So something like that. This is actually very important, and it makes everything super, super easy. So what do I want to say about this? If you have this case, this case, all of this stuff is kind of like the model that we're going to follow. If we have an odd degree polynomial, then it's going to mimic these lines. So odd degree polynomials, and I'm going to show you an example. Odd degree polynomials have similar properties as this. What do I mean similar properties? Well, I mean if you have an odd degree and a lead coefficient of positive, that means on the left side we'll be going downwards and on the right side we'll be going upwards. That's what I'm focusing on. The end behavior. What? Yeah, so it's what happens at the ends. If you have an odd degree polynomial and a negative leading coefficient, then we're going to be going up left on the left side and down on the right side. It's going to look like a negative slope. And I'll show you what I mean in a minute. And then, so that similarly for even degree polynomials. Even degree polynomials have a similar property where if the degree is even, meaning the highest exponent is an even number, that's pretty descriptive, and you have a positive lead coefficient, then you're going to be opening upwards. Okay, I mean it might look like something weird, but it'll still open upwards. And then if you have an even degree with a negative coefficient, it might look weird, but it still opens downwards. So we're just going to remember that stuff. Let me show you an example. Describe the end behavior of the graph of the function. Okay, and then we have d of x equals all this stuff. But wait a minute. This is not in standard form. I want to put it in standard form. I want to have everything in order. Remember, standard form is where the highest exponent goes first. And that's this, right? That's exponent of 5. So that one should go first. So I'm going to rearrange these terms. And I'll keep the signs with it. So the first thing should be negative 5x to the 5th. And I'll put a little check mark there. And then what's the next exponent? That's the x to the 4th. So I keep the negative in front. Minus 12x to the 4th. Put a little check mark there. What else? Third, I don't have any third exponent. Okay, there must be the 2 minus 18x squared. A lot of people will forget the negative. Don't forget the negative. Put a check mark there. 2 exponent of 1, that's this one, right? If there is no exponent, it's an exponent of 1 minus 2x to the 1, or just 2x. Put a check mark there. And then the last thing, it's a positive 11, so plus 11. Okay, so describe the end behavior. And this is actually important, and it might be a little bit confusing, but the left side, we can say for the left side, let's talk about the left. Well, actually, first I'll write it how we have with these things. What do we have, an odd degree or an even degree? Well, the degree of the polynomial is just the highest exponent. So this is degree 5. So this would be odd degree. So it looked like this. something like that. And do we have a leading coefficient that is positive or negative? Negative. We have a leading coefficient that is negative. So our graph should look something with like a negative-ish slope. Looks like this. I mean, it'll do something weird in the middle, like it doesn't matter, but overall, it looks like a negative slope. It can do whatever it wants in the middle there, but it'll be a negative slope. I don't know exactly what the graph looks like, but it's okay. So, how do I say this? Describe the end behavior. So it looks like a negative slope, but the way that you describe the end behavior is you say, for going towards the left, we're going upwards, right? Going towards the right, we're going downwards. So let me write that using math terms. How do we say going to the left? As x approaches negative infinity, that's to the left. That's to the left. I'll write that. Okay, so as x approaches negative infinity, that's going to the left. What is the function doing? It's going upwards, right? And that's positive infinity. So as we go to the left, what is our function? G. Our function is called g of x. G of x approaches positive infinity. Maybe I'll be explicit. Positive infinity. That means up. Because g of x is our function. Okay, what about to the right side? Well, if to the left side is negative infinity, then the right side, x approaching positive infinity, it would be, yeah, just positive infinity. I'll just say plus infinity. As you go to the right, what is happening to our function? It's going downwards. Well, how do you say it's going downwards? Well, same like this. G of x must be going to negative infinity. And then that means down. So that's all you have to write. The way you say to the left is x, because x is left and right. And positive or negative infinity is to the left. Positive infinity is to the right. Okay, that's pretty easy. And then g of x, that's like your y. That's up and down. So this should make sense as well. Positive infinity is up. Negative infinity is down. So that's how you describe the end behavior. If you had something like this, well, that means to the left, you're going up. And to the right, you're going up. So then you just write this part twice. Oh, that's pretty easy. That's how you describe end behavior. I'm going to be done with this video.